Hello, my name is Ken, and I'm a lead trainer for JB International on the C++ courses. I'm just going to give a little demonstration of something which is similar to an exercise given on the introductory C++ course. And it's to do with illustrating both inheritance and polymorphism. So for this purpose, I'm using Visual Studio, although there are a wide range of different development environments which could be used for this, as C++ is a standard language. It doesn't really matter which development environment is used, but it's just convenient to make use of this now. So we have here just a simple console application at the moment. And to illustrate inheritance and polymorphism, I'm just going to consider a sort of a simple example, the idea of different kinds of shape. And on the course, the sort of rationale for this demonstration would be given in sort of more detail. But assuming I wanted to create a number of different shape types, the idea would be to have a base type, in this case, shape. And in order to provide the sort of position for a shape, we could just have a simple point structure. So we can define a class to represent our shape. And here we're intending to use this point structure. So that could be defined as simply as this. So simply using integers for illustration purposes. It doesn't really matter about the actual size of the sort of built-in type used for the sort of X and Y coordinates, but just considering a simple structure for a point which will be used to define the position. So my shape class has a position and a constructor to initialize that position data member, and then a simple draw member function in order to output the X and Y position. And of course, the idea being that the drawing in real life would actually be doing some proper drawing, but for demonstration purposes, this suffices. And of course, making sure that the draw member function is const, so keeping const correctness. As the draw is intended to draw the item, there would be no intention really to actually modify the data members within the shape class. We could then simply create a shape object, of course being initialized with the position, and then call the draw member function. And if I simply run that now, I'll see the appropriate output. And there is my output corresponding to calling draw. So far, that's just a simple class which we can initialize and get some output. But the idea is that we want some sort of hierarchy of shapes. On that basis, I can then define a rectangle class. And of course, the rectangle will inherit from shape in order to take on board the position. And so the rectangle will simply have a height and width if I'm using that to sort of represent the sides of the rectangle. And then we have a constructor which fully initializes the rectangle, initializing the base class part of the rectangle, and then the width and height. And in this case, a draw member function and calling the base class draw in order to output the position, and then outputting the width and height. If I now go to create a rectangle, and I'll comment out the original code. we can now see the position and the width and height. So that allows me to create a rectangle. And in principle, I could create other shapes inheriting from shape class as well. And so that common part, the common position, could then be reused. However, whilst I've now used inheritance, let's consider polymorphism. And for this purpose, I'm going to create a display function taking a shape by reference. And so this just calls draw and then outputs a new line character. And so instead of calling draw directly there, I can simply say display shape, passing a rectangle. As a rectangle inherits from a shape, I can pass that to a reference to a shape. And run this now. And at the present moment, I'm only seeing the position, not the width and height as well. And the reason for this is because within that display shape, I'm passing a shape by reference. And therefore, when I call draw currently, it's calling the shape's draw member function, because the draw member function in shape is not virtual. In order for polymorphism to work, I need to mark the member function in the base class as virtual. And when I now run this again, this is now making use of polymorphism, and the rectangle's draw member function is being called, which involves a runtime lookup in order to find the appropriate draw member function to call for the object on which that member function is acting. And so this is now illustrated both inheritance and polymorphism.